Welcome to the image swap. You're doing good.
Let me see how it actually looks. Welcome, we're the Night Signal team. My name is Aiden Jordan.
I'm Caden Peters.
I'm Luis Campoy.
I'm Ricardo Garcia.
And I'm Tiago dos Santos. And together, we built the Night Signal. The Night Signal is a large projection system inspired by the classic Batman movies.
This project's main stakeholder is UCF for use at UCF events. This project was brought to us in idea by Pete Alfiris.
Our main goal for this project was to create a wow factor for fan engagement at these events.
The objective of Night Signal is to produce a system that is reusable and has low-cost operation.
The possible broader impact of our project is for search and rescue and safety purposes. For the Night Signal system, we chose to use stepper motors due to their high precision and torque. All these stepper motors are driven by DM542 drivers due to their high granularity and smooth control at slow speeds. For the elevation axes, we are using two high-torque NEMA 23 motors on 1 to 30 worm gearboxes. This high torque is needed to overcome the large moment inertia of the optical chamber and the weight of the system. For the azimuth axes, we are using standard NEMA 23 on a 1 to 17.5 pulley system driven by a GT3 9mm belt turning a 12-inch Lazy Susan bearing. These large gear reductions are necessary due to the overall size of the system. The system size was dictated by our optical physics. The optics are based on a single lens projector using the thin lens equation. Our projection lens is a 300mm PMMA Fresnel lens. This lens has a focal length of 2000mm or 2 meters. This focal length was chosen to provide a large range of usable projections targeting between 50 and 100 meters. In practice, this means that the distance between the projection slide and the lens is 2 meters. There is an additional length at the rear between the light and the projection slide, which is 18 inches. The entire length of the optical system, including the light mount and cooling mounts, is pushing 9 feet in total length. Our projection brightness targets in the 50 to 100 meter range are 1000 to 5000 lux, or luminous flux. This brightness is equivalent to a bright classroom projector all the way up to a bright LED studio panel. For the frame materials portion of the Night Signal project, we ended up choosing aluminum extrusion bars instead of stainless steel bars for its price to manufacture and for its density being lighter than stainless steel, along with having good mechanical properties such as high yield strength and good thermal properties, since we're going to be dealing with a lot of heat due to the light source being a very powerful light. We were using the aluminum extrusions for our optical chamber along with the frame itself, which is designed to withstand the whole weight of the optical chamber.
The Night Signal uses a closed-loop liquid cooling heat exchanger to keep the flashlight operating at maximum brightness without overheating. And so the flashlight aluminum housing can reach about 51.5 degrees centigrade, causing it to reduce light output once it gets too hot. To solve this, we removed the original lens casing and created a custom hollow mold that lets the water flow directly around the aluminum body, maximizing the conductive heat transfer into the cooling. The heated water is then pumped to two radiators where fans remove the heat through forced convection, cooling the water before it cycles back through the mold. This creates a continuous loop of heat absorption and dissipation. And to assist with displacing heat from the flashlight, instead of using the stock battery handle, we have wired the flashlight head to a 16-volt LiPo battery for higher sustained output.
The image swapper serves as the critical interface between our 120,000 lumen light and the final projection. It features a carriage that was designed to hold up to 7 UCF themed pictures and is driven by a NEMA 17 lead screw motor. This provides the torque necessary to move the carriage into position and the necessary precision to align the pictures with the light. It also features another lead screw motor to lift up and down the slide into position, and again, this will also provide the necessary resolution that operated to be able to have a clear picture. The carriage rides on aluminum extrusion, and it acts as a guide as well for the lead screw motor and the carriage. This whole system is going to be operated by a wired remote, and this will ensure no latency, and it will be highly reliable when operated in all weather conditions.
For the night signal, I designed a 4-layer PCB. I went with this for the addition of a dedicated power and ground plane for the reduction of EMI. This board is powered from 24 volts and has switching regulators for 12 and 5 volts and a linear regulator for 5 to 3.3 volts. This was all designed with safety in mind and uses the necessary fuses and diodes. This PCB functions as the main control board of the project. The microcontroller I chose was the ESP32. This was due to its high clock speed and dual core capabilities. I decided to use a shift register, allowing us to both preserve the native pins of the ESP and shift the 3.3 volt logic to the 5 volt needed for the drivers. This was used to control the 5 stepper motors with a clean and scalable architecture. I also used a standalone level shifter for all the necessary 5 volt logic devices that weren't being passed through the shift register. Even though this controller has wireless capabilities, we chose to use a tethered remote for controls due to the high sensitivity of the environments this will be used in, like the football games. The controller is tethered to the electronics box via a shielded Ethernet cable. A dual-axis potentiometer-based joystick and 2 buttons is used for the control of the system. The controller also features a keyed switch and an emergency stop button for added safety. Other than the PCB, this project features extensive power delivery circuitry. The flashlight is powered by a 16-volt LiPo battery that extends the runtime from the stock battery by over 3 times. This flashlight circuit also has a 70-amp circuit breaker and a high-current contactor that is controlled by the e-stop. The control circuitry is powered by a 12-volt gel battery. This all goes through a 60-amp breaker before reaching the electronics box. This is boosted to 24 volts for powering the PCB and the stepper motors. There is both a 12-volt and 24-volt fuse panel for all the peripherals. The 24-volt fuse panel that powers the motors is in line with a 24-volt relay that is also controlled by the e-stop. When the e-stop is pressed, both the flashlight and the 24-volt devices are cut from the power via the relays. This leaves only the 12-volt cooling system and the PCB powered. I was just thinking of Ricardo scrolling.
Go. For the night signal.
Tell me about it.
Welcome. We're the night signal team. My name is Aiden Jordan.
I'm Caden Peters.
I'm Luis Campoy.
I'm Ricardo Garcia.
Dude, you do not have to say it like that.